What I want to do now is to go over the worksheet that I assigned you, the first page, the first sheet, and work and see how you accomplish these problems. If you start out, first one says find the length of the hypotenuse of an isosceles right triangle. Well, that would mean this is 45 and 45. Whether it looks like on my diagram, that's the way I have it. So you got to look for the hypotenuse, so we don't know that. But we do know that the leg on number 1A is 6. That means both sides, or both legs, are 6. Now using theorem 9-8, it says the hypotenuse is equal to the leg times the square root of 2. So we're looking for the hypotenuse, so the x equals, and the leg is 6 on the square root of 2. And so the answer to number 1A would be 6 on the square root of 2. Now, let's take number 1B. Starts out with a 45 on an isosceles triangle. It says to find the length of the hypotenuse if the legs are 3 on the square root of 2. Now, again, you would write theorem 9-8 as the hypotenuse is equal to the leg times the square root of 2. Now, so the hypotenuse is equal to 3 on the square root of 2 times the square root of 2. Well, that means you would say 3 times, and you would say inside times inside. So the answer is 4. So the hypotenuse would be 3 on the square root of 4. But the square root of 4 is 2. So the answer again is 6. Now that is number 1B. Now let's go to 2A. Again, you would use it says, find the length of a leg of an isosceles triangle. That's 45, 45, 90, and this is the hypotenuse, and these are legs. And it says on number 2A, find the length of a leg if the hypotenuse is 12. Again, we would use theorem 9-8, which says the hypotenuse is equal to the leg times the square root of 2. Well, the hypotenuse is 12. Replace that. Now, we want to solve for legs. So we're going to divide by the square root of 2, and what you do to one side. But here we have to rationalize the denominator, which means to multiply the denominator by the square root of 2. And the square root of 2 would be times itself 2. Now you put on top the square root of 2, so that's 12 on the square root of 2, which means the 2 here and the 12 will cancel, and the answer is 6 on the square root of 2. Now that's 2A. Let's go to 2B. Again, you have a 45, 45, 90-degree triangle. The side opposite the right angle is the hypotenuse. The other sides are called legs. And it says on number 2b, the hypotenuse is 6 on the square root of 2. So we'd use theorem 9-8, which says the hypotenuse is equal to the leg times the square root of 2. Now that's in a 45, 45, 90 degree triangle. So the hypotenuse is 6 on the square root of 2. And this is leg, square root of 2, divide by the square root of 2. And the answer would be C. Cancel 6. And that would be the way you do number 2B. Now number 3A. Now number 3A, we move to a 30, 60, 90 degree triangle. That's 90. This is the 30. And say this is 60. Now this is the hypotenuse. Now these are legs, true enough. But the side opposite the 30 degree is called the shorter leg. And the other one is called the longer leg. And so on number 3A, it says find the length of the hypotenuse, that's x, if the shorter leg in number 3A is 8. Now it does not say to do the longer leg on this particular problem, just the shorter leg. So using 30, 60, 90, and of course you know that's theorem next one is 9.9. And it says the hypotenuse is equal to twice the shorter leg. So in this particular problem, it says to find the hypotenuse if the shorter leg is 8 centimeters. So the hypotenuse would be 16 centimeters. Now that's number 3A. Let's do 3B. Again, you have a 30. This is number 3B. You have a 30, 60 degree, 90. This is the hypotenuse. And this over here we abbreviated as SHL, which is the shorter leg. Now number 3B, it says find the length of the hypotenuse, that's x. The shorter leg, now that's going to be 2 on the square root of 3. So theorem 9.9, let me write that again. 9.9 says the hypotenuse is equal to twice shorter leg. So the hypotenuse would equal 2 times 2 on the square root of 3. So the hypotenuse is 4 on the square root of 3. Now that is how you would do number 3, A, and B. Now we on number 4, A. Again, you're using a 30, 60, 90 degree triangle. This is the right one. This is the hypotenuse. This is 30, 60. Now the side opposite the 30 degree angle is shorter leg. The other one is called the longer leg, LL. And it says find the length of the hypotenuse of a 30, 60, 90 degree triangle whose longer leg is 10 on the square root of 3. Now to find the hypotenuse, you would say 2 times the shorter leg. But here's the situation. We are not given the shorter leg, we are given the longer leg. So what we need to do is use part 2, which says the longer leg is equal to the shorter leg times the square root of 3. And so in this particular case, the longer leg is 10 on the square root of 3. So replace it. Divide by the square root of 3 on both sides. Then the square root of 3 cancels, so the shorter leg is equal to 10. But our objective is to determine the hypotenuse. So over here we write the hypotenuse equals 2 times the shorter leg. But the shorter leg is 10. So the hypotenuse is 20. And of course it says feet here. Now that's how you would do 4A. Now let's talk about 4B. Again, we're talking about 30, 60 degree angle. 30, 60, 90 degree angle. That's 30. That's 60. And that's the hypotenuse. Now we want to know, it says on number 4B, find the length of that hypotenuse. Now this is the longer leg, the side opposite the 60. And in 4B, that is 6. And we're looking for the hypotenuse. Now, remember, now to find the hypotenuse, that's going to be 2 times the shorter leg. But we're not given the length of the shorter leg, we're given the length of the longer leg. Well, on theorem 9.9, the longer leg is equal to the shorter leg times the square root of 3. So in number 4B, the longer leg is 6. So we'll divide both sides by the square root of 3. But you cannot take 6 and divide it by the square root of 3. So we have to rationalize our denominator. So what that means, we're going to have to multiply the denominator by the same thing. Or, in this case, square root of 3. And the square root of 3 times the square root of 3 is 3. On top, you would multiply that as well. Now, you cannot multiply a number outside the radical times a number in the radical. So you just write them side. But you do cancel, and the answer is 2 on the square root of 3. Now, so we're looking for the hypotenuse. So you'd say the hypotenuse is 2 times the shorter leg, which is 2 on the square root of 3. That's the hypotenuse is equal to 4 on the square root of 3. Now, that is number 4B and 8. Now, number 5 gives us a different look. It says, find the length of the altitude of an equilateral triangle. Now, if you know about an equilateral triangle, all 3 sides are congruent. Now, so you draw the altitude, and what that altitude does, it makes a right angle here. Now this angle is 60, and this angle is 60. If that angle is 60, and we got a right angle, then this small angle would be 30 on both sides. But we don't need 2 triangles. We just need one. Now, that red line is called the altitude. But in our 30, 60, 90 degree, that's the side opposite the 60-degree angle. So we need to call that also longer leg. So he takes on two names. One name is the altitude. That's in the equilateral triangle. But in the 30, 60, 90, he is going to be the longer leg. And so number 5 says to find the altitude, which is the longer leg. But it says find whose side, this is the side of an equilateral triangle, but in the 30, 60, he's the hypotenuse. He's got two names. In the equilateral, he's the side, and in the 30, 60, 90, he's the hypotenuse. And so number 5 says, find the altitude who has a side of 6, or the hypotenuse is 6. Now, our objective is to find the longer leg. Well, you would say the shorter leg times the square root of 3. But we're not given this shorter leg. We are given the hypotenuse. Now the hypotenuse says 2 times shorter leg. Now we're trying to find the longer leg. Now the hypotenuse is 6 equals 2 times the shorter leg divided by 2. The shorter leg is 3. Now, so come back over here. The longer leg is equal to the shorter leg times the square root of 3. And so, that is number 5A. Now let's do 5B. Again, you start off with the equilateral triangle. Now, we're going to draw the altitude. Now that forms a right angle. Now, this angle is 60. Of course, I said earlier that all of them are 60. This would be 30. Now, this is the side of an equilateral triangle, and this is the altitude of an equilateral triangle. But we're talking about using a 30, 60, 90 degree triangle. And we're trying to find now in a 30, 60, 90, this side would be called the hypotenuse. He's the side opposite the right angle. This side over here, this the altitude, he's the longer leg. And the problem says to find the length of the altitude, which is the longer leg, if you are given the side. Now the side on number 5B is 2 on the square root of 3. But in the 30, 60, 90 degree triangle, he's the hypotenuse. Now we're looking for the longer leg. Again, you can find it by taking the shorter leg times the square root of 3. Well, notice what shorter leg? No, the hypotenuse. Well, Theorem 9.9, it says the hypotenuse is equal to twice or 2 times the shorter leg. So, the hypotenuse is 2 on the square root of 3. So we just multiply, divide by 2. Now these 2's will cancel. So the shorter leg is equal to the square root of 3. Now, what we're looking for the longer leg. Well, the longer leg is said to be the shorter leg, which is the square root of 3 times the square root of 3. So the longer leg would be 3. Now that is how you would do 5b. Now we're moving on to number 6. Okay, 6a. Again, on number 6, we're talking about an equilateral triangle. Same thing as earlier. Draw the altitude. Now, this would be called a side. This would be called the altitude. Now, remember, they are all 60-degree angles, but this would divide up into 230s. But we're not wanting but one. So the altitude now would be the longer leg, and the side would be the hypotenuse. Now it says find the length of the side, which is the hypotenuse, if you are given the length of the altitude. So, now remember the altitude in this case is 6. Well, the altitude is the longer leg of the right triangle. And so to find the hypotenuse, you would say 2 times the shorter leg. We do not know the shorter leg, so we've got the longer leg. Well, the longer leg is the shorter leg times the square root of 3. So, we would replace the longer leg with 6 and determine what the shorter leg is. Now, here we go dividing by a radical. Now, we have to rationalize our denominator, which means to multiply by the square root of 3. Well, that's going to be 3 on bottom, cancel. So you get 2 on the square root of 3 is the shorter leg. Now, well, we're trying to find the hypotenuse. Well, just come over here and multiply 2 times the shorter leg, and the answer would be 4 on the square root of 3. That is number 6a. Now we want to move down and do 6b. Again, you're looking at an equilateral triangle with the altitude being drawn, forms a right angle. Now this is the side of the equilateral triangle. These are 60s. Because they're equilateral, all the angles are the same, and to be that is 60. But the altitude divides the 60 into 230s. Now this is called the altitude. Well, we're talking about the right triangle, so he's going to be called the longer leg because he's opposite to 60 degrees. And then the side is the hypotenuse. Now, it says on 6b, find the side. That means find x. If the length of the longer leg is 6 on the square root of 3. Well, to find the hypotenuse, you would say 2 times the shorter leg. I don't know the shorter leg. I know the longer leg. Well, that's okay. The longer leg is the shorter leg times the square root of 3. Now, the longer leg this time is 6 on the square root of 3 equals shorter leg times the square root of 3. Divide by the square root of 3. And the shorter leg is 6. But we need the hypotenuse, or the side of the equilateral. They're the same, even though they're 2 different words, they represent the same value. So the hypotenuse is 2 times the 6, which is the shorter leg, and so that becomes 12. And that's how you would do the first 6 problems on that first worksheet. Now, that leads us down to number 7. Now, people, on number 7, you're going to see how far we can go with this. Now, what you've got to recognize that we have a big right triangle. And I'm going to trace over that, if you would let me, with this blue. Okay? Now look at the blue. If this angle is 30 and this angle is 60, then that angle is 90. And they are telling us that the length of AB is 8. And they want you to determine the rest of the sides. Now stay within the blue triangle, the big one. Stay within the big one. This side that I have here, we call that the hypotenuse, because he's the side opposite the right angle. Now, this side here would be the shorter leg, because he's the one opposite the 30-degree angle. Well, to find BC, which is the shorter leg, you would take the hypotenuse equals 2 times the shorter leg. Well, the hypotenuse is 8. Here's the hypotenuse down there. He's 8. So you say times, divide by 2, and the shorter leg, which is, in this particular problem, BC, is equal to 4. So on our list up here, under BC, we would write 4. So this is 4. Now stay within the big blue triangle. Okay, see within the big blue triangle, then this side over here would be called the longer leg. Well, the longer leg is equal to the shorter leg times, let me erase that and do better. The longer leg is equal to the shorter leg times the square root of 3. So the longer leg would be, now remember the shorter leg is 4 on the square root of 3. But now the longer leg is AC. So on the chart you would write 4 on the square root of 3 under AC. Now, that leaves us CD, AD, and DB. Well, basically what that means then is we're going to have to look at a different triangle. Now, let's see how confusing this is if I go up here and use black again. Now, look at the fact of CD. Now, that means, just look at this small triangle on the right-hand side. Can you see me tracing over the small triangle on the right side? Okay? Now, just in the smaller one, this angle is 60, and this is 90, so this angle is 30. Now, don't be looking at the arrows, you know. Alright, this is 30. This is that. Now, here you go. This side, now that's not the shorter leg. That's not the shorter leg in this particular case. That would be the hypotenuse in the other one. Now, in the small triangle, this side would be the hypotenuse, which is still 4. But we're looking for, well, either side. We can look for DB, he's the shorter leg, and this side would be the longer leg. Now, we have the hypotenuse given. So the approach that we'll take here is we'll go the hypotenuse equals 2 times the shorter leg. Well, that means right here that would be DB. So we're looking for DB. Now the hypotenuse is 4. Now you take 2 times the shorter leg. Now remember, the shorter leg is DB. Divide by 2, then DB is 2. So this side is 2. Now come over here where the chart is, and under DB put 2. Now, that leaves us the longer leg. Well, the longer leg and the one on the right now, the little small one here on the right, is equal to shorter leg times the square root of 3. So the longer leg is equal to, remember the shorter leg is 2 on the square root of 3. Now the longer leg is 2 on the square root of 3, but in the triangle that is side CD. Now, got one more side, one more segment to find. What is it from A to D? And of course, you know, segment addition possible. If the entire length is 8 and this is 2, what would you add to 2 to get 8? And that would be 6. Had nothing to do with that theorem, just remember that first postulate we learned at the first of the year. And AD then is 6. And that is the way you would do that problem. First, use one triangle, then use another. Let's try number 9. Okay? On number 9, you have CD is 4 on the square root of 3. Now CD is the length in 2 triangles. The one on the little one on the left, and I'm going to trace over it in blue. So I'll try to see. CD is the side in this triangle right here. That CD is in that side of that triangle in blue. Now, that's the 30-degree angle, so what would you name this side? In the blue is shorter leg. And this is a right angle, so you would name in the blue, this is the hypotenuse. And in the blue, from here called A to D, that's the longer leg because he's opposite this angle. Well, if this angle is 30 and one angle is 30 and one is 90, the other one has to be 60. Now, let's say we find the hypotenuse of this. So, that's the hypotenuse is equal to 2 times the shorter leg. So the hypotenuse would be 2 times 4 on the square root of 3. That's the shorter leg if you're looking up here. So that means then the hypotenuse is 8 on the square root of 3. So this side is 8 on the square root of 3, but that's from A to C. So AC on the chart is 8 on the square root of 3. Now look at the blue. Now stay with the blue. Right here, the blue. LL. Longer leg. Now he's found by taking the shorter leg times the square root of 3. Now, so the longer leg is equal to, now remember the shorter leg is how much? 4 on the square root of 3 times the square root of 3. Now, we got to know how to multiply radicals. That's 4 times, now the square root of 3 times the square root of 3 is 3. So, the longer leg is 12. So this side is 12. Well, now 12 is from A to D in the blue. And that's AD. So on your chart, where you find AD, you would put 12. Now, you still got to find the other section. Now let's go back and you read it again. Now remember, CD was what was given to us to start off with. That was given right here. Okay? Now, that was given. But this time, let's do the smaller triangle on the right. Now that is a 60-degree angle, so he's 30. Now, in this particular triangle, the side opposite would not be the shorter leg, he would be the longer leg. So, we know in theorem 9-9, the 30-60-degree, 90-degree triangle, the longer leg is equal to the shorter leg times the square root of 3. And so in this particular problem, the longer leg is 4 on the square root of 3. You solve for the shorter leg by dividing the square root of 3. That cancels now. We got the shorter leg, or this side, this is the hypotenuse, and that's the longer leg, so this is the shorter leg, and he is 4. Now that's going to be from D to B, and that means 4 goes right there on the chart. 4 is DB. Now, we need to know what the length of the hypotenuse is. Well, we know that by theorem 9-9, the hypotenuse is equal to 2 times the shorter leg. Well, we know the shorter leg now is 4. So that's 2 times 4, and the hypotenuse would be 8. Now this side would be CB, or BC, and that is 8. Now what we need to know, though, is how far is it from A to B? But we remember about the segment addition postulate. If AD plus DB equals AB. So what is 12 plus 4? And that answer is 16. And not getting away from segment addition postulate. There's 2 of them. That was number 7 and number 9. Well, let's see if we're making any progress. See if we're making any success. Let's move on down to the 12. number 12. Now number 12, it says AC again. Now AC is 8 on the square root of 3. Now let's take the blue pen again, and let's trace over AC. And then let's go to the base D, and then back up to C. And not dealing with any other triangle, just that. Well, this is a right angle. So this side with an 8 on the square root of 3 is called the hypotenuse. Now this is the 30-degree angle, so this blue side would be called the shorter leg. Well, then the third side, AD, this bottom side, would be called the longer leg. And so, we have theorem 9-9. Look at just the blue triangle. We have the hypotenuse. Well, theorem 9-9 says the hypotenuse is 2 times the shorter leg. So, if the hypotenuse is 8 on the square root of 3, divide by 2. 2's cancel with the 8, so that would be 4 on the square root of 3, which would be the shorter leg. Now that means this side over here with the word shorter leg would be 4 on the square root of 3. Now, what that's going to be, if you look at the chart, from C to D. So CD on the chart is 4 on the square root of 3. Now let's find the longer leg. Well, we know, we are sharp, we've learned it by now. The longer leg is equal to the shorter leg times the square root of 3. So the longer leg is equal to, now the shorter leg is down here, and that's 4 on the square root of 3 times the square root of 3. But again, as I had said earlier, we have got to know how to multiply radicals. And so the square root of 3 times the square root of 3 is 3. Now multiply the longer leg is 12. So this side is 12. But remember, that's from A to D is 12. So on our chart, AD is 12. Now, let's go back to the rate. Now notice that this over here where we have 4 on the square root of 3, let's trace over that side, put it back in red. Now, put it back in red. Well, let's continue on and make us a right triangle. So we got the little small triangle on the right. Now, this side this side would be called the hypotenuse. Now this angle is 30. So this would be called the shorter leg. Now in the blue triangle, CD was the shorter leg. That's in the blue. Now in the red triangle, he's the side opposite the 60-degree angle. So he has to take on the other name of longer leg. Well, if we've given the longer leg, what do we know about the longer leg is that he is the shorter leg times the square root of 3. Now the longer leg is 4 on the square root of 3. If you divide by the square root of 3 on this side, he cancels. Well, what you do to one side, you've got to do to the other, and that cancels. So 4 would be the shorter leg. And now the shorter leg is 4 right here. but that's from D to B. So on your chart, DB would be 4. That leaves us then to determine what the hypotenuse is. Okay. Now, that means the hypotenuse is 2 times the shorter leg. We've been doing this now. I hope you have began to understand these two theorems. So the hypotenuse is equal to 2. Now right here we found the shorter leg to be 4. So the hypotenuse is 8. Now, but on the diagram, that would be from C to B. Well, BC then would be 8. That leaves us from A to B. Now we have learned that there is the segment addition postulate, so that would be what? 16. Now that should give you a good indication on how to accomplish. Now there are some other problems. You can continue to look. I believe you got the ability now to answer the others. 13 and 14 is 45, 45, 90. You know that they, on a 45, 45, the hypotenuse is equal to the square of leg times the square root of 2. But what I would like for you to do now is to complete the second worksheet by yourself. With this, with the information that we went over today, I hope that would be a good example to have.